Hello and welcome to my channel. Today I'll be doing Unit 4 of Chemistry, the electron arrangement in atoms. So let's talk about protons and electrons, what they do. Protons identify the atom and electrons show the atom's personality, so their reactions, their properties, and the bonds that they form. So let me explain the quantum model of the atom. Basically, electrons make up light, which makes up energy, which makes up waves. So the quantum model just is focused on the behavior of electrons. So to remember that, we could say electrons, light, energy, and waves. Okay, so wavelength. The symbol is an upside down Y. It's a Greek letter actually. And it's measured from crest to crest. So you see right here to right here is one complete wavelength. So it's a complete cycle of the wave. And it's measured in meters or nanometers to kilometers. And this is called a trow right here. And then this right here is the amplitude. Okay, frequency, its symbol, and when I say symbol, I mean in an equation or a formula. Its symbol is a V, and it's the number of waves that pass a fixed point in a set amount of time. For example, it would be the time between breaking waves on a beach, or the time between the ups and downs in an anchored boat. And it's measured in waves or cycles per second. And the label is hertz. Okay, energy. So its symbol is an uppercase E, and it's measured in joules. There are many different types of waves, such as water, sound, or electromagnetic radiation waves, or EMR. So, all EMR waves, they travel at the speed of light, and they have the same relationship with energy, wavelength, and frequency. So here I've listed the 7 different, I guess you could say, types or parts of the spectrum, of the EMR spectrum. So I've ordered them going from longest to shortest wavelength, lowest to highest frequency, and lowest to highest energy. So to remember this order, you could think radio waves, microwaves, infrared light, visible light, ultraviolet light, X-rays, and gamma rays. So I'm just going to go back real quick. So as I mentioned, part of the EMR spectrum is the visible light spectrum. So you see we have all the different colors. Oops. So obviously, it's the only light that you can see, all of the colors. A lot of people know it as Roy G. Biv. I don't know, it helps me remember it better. So I've listed the colors of the visible light spectrum in order from longest to shortest wavelength, lowest to highest frequency, and lowest to highest energy. Alright, so now I'm going to talk about the different traits of the EMR spectrum. So first of all, we have gamma rays, which are so powerful. They're found in the sun and radioactive elements. They're used for irradiation, which is irradiation sterilizes food and medical equipment such as Band-Aids, and it also is used to kill cancer. Okay, the next type is an X-ray. It's found in the sun and the stars, or electricity and the element tungsten. Too much of it can give you cancer, but it's used in astronomy for medical reasons and at airports, and I mean, most of us have had experience with X-rays. When we break a bone, get an X-ray. Okay, ultraviolet light. So, it's found in a lot of places such as the sun, welding, black light bulbs, and tanning beds. But you've probably heard about this with the controversy over tanning beds. It can give you skin cancer and cataracts, and the humans can see it as you can see it in a sunburn, and insects can see some parts of the ultraviolet light. So for example, for mating, they can see ultraviolet light, like the different colors on each other. And ultraviolet light is used to see pictures of the sun and the planets and the stars, and also, black light bulbs and tanning beds. All right, next um, part of the EMR spectrum is visible light. It's the only part of the spectrum that we can see. As I mentioned before, Roy G. Biv, red, orange, yellow, green, blue, indigo, violet. So this order, lowest to greatest energy, longest to shortest wavelength, and lowest to highest frequency. All right, so next type, um, or next part of the EMR spectrum, would be more proper to say it that way, I guess, is infrared light. And the key word you want to remember with this, with infrared light, is heat, because it comes from anything giving off heat. So it's used for night vision, security systems, heat-seeking missiles, and to detect hurricanes. All right, next up is microwaves. And I'm not talking about the actual microwave that is in your kitchen, like the actual box-shaped microwave. Those use microwaves, hence the name, but these are, actual waves that are part of the EMR spectrum. And they're used for communications, radar equipment, and food preparation in your microwave. And microwaves work by exciting the water molecules with these microwaves. And compared to gamma rays, they're really not that harmful. Only certain frequencies are harmful to you. But these guys, you really don't, have to worry about them being really dangerous or anything. All right, now we have radio waves. They are the weakest in the spectrum, the EMR spectrum. They're used in astronomy and for radio and TV, cell phones, and communication. All right, so here's my study stack. There are just a few questions about the EMR spectrum and everything. So here's the link. I would strongly advise you to check it out. Okay, so earlier in the video, I mentioned that all parts of the EMR spectrum, they have the same mathematical relationship relating to energy, frequency, and wavelength. So energy and frequency have a direct relationship. This is the formula. Energy equals H, which is Planck's constant. This is Planck's constant, times frequency. Okay, so the formula for wavelength and frequency and energy and wavelength, they all have indirect relationships. So this is another formula. Energy equals Planck's constant, which is right here, times the wavelength. And also c, which is the speed of light, equals wavelength times frequency. And this formula right here is the same as this one. All right, so that's a little bit about Unit 4 of Honors Chem. I hope it helped. Thanks for watching.